gents, this is our next lesson, okay? And today we're going to learn how to calculate the surface area and volumes of cylinders. What are cylinders? Hang on there, don't go anywhere. Okay? This is a cylinder, okay? Like a tin can, okay? So it's also a kind of a prism because it has two bases. Okay? Got the top base and the bottom base, and they're identical. Okay, so it's also some kind of prism, but yeah, obviously it doesn't have sides. Okay, it just have one side. So we're gonna start by calculating. Let's start by calculating the volume. The volume is actually easier. Calculate the volume. We're going to use the same principle that I wrote for you last lesson. Volume of prism are the area of the base and the distance between the bases. So the base are basically just a circle. And they're just a circle. And I know how to calculate area of a circle. So let's say this is the measurements that I have. The radius is 4 and the distance here is 5. So the area, okay, the area of the circle is going to be pi r squared. What is r? Okay, it's 4. So pi times 4 squared. Okay. Now, the distance between, here it says distance between the bases is 5. Okay, so I'm just going to write it down like this. Okay, so the volume is going to be pi r squared times the distance between the two bases, which is 5. So I'm going to times it by 5. Okay, okay, and then I'll just put that into the calculator. Okay, so just get my calculator. Right, 4 squared times 5 times pi. Doesn't matter which order you do that. And I got the answer again is 80 pi. Now, 80 pi. Now, sometimes you could leave your answer like that. Only if they tell you to give your answer in terms of pi, you can leave it like that. But if they don't say anything, you actually need to give a decimal place. So you press the S and D button, and then you get, if they don't say anything, 2 decimal places. Okay? So 251,3, rounding it up. Now, what will be the units, do you reckon? Okay? The units I've got here is centimeter and centimeter. Now, this is volume. Okay? So I'm going to multiply centimeter times centimeter times centimeter. The answer will be in centimeter cubed. Okay? Now, I'm just going to write down the volume of a cylinder. I'll write a little formula. Okay? It's going to be pi r squared, because this is what we did. Pi times the radius squared times the distance between the bases, which often we can call it the height. It's like the height of the cylinder. So it's going to be pi r squared times h. Okay? I'll draw another little cylinder here. Okay? If this distance is r, the radius, and this is h, that's the height. Okay? It's the same height. And it's going to be pi r squared h. Okay? Let's move on to the surface area. Now, if you were to open this, so you'll take two of the bases, you're going to get 2 circles, okay? Right? Now, if this was made out of paper, obviously it's not made out of paper, so I can't do it, but if this was made out of paper, and I would cut it, okay, and open it, what shape will I get, do you reckon? What shape will I get if I manage to cut it with scissors? Imagine you've got a toilet roll, okay, just the roll itself, without the paper, and you cut it, and then you spread it. You're going to get a rectangle, right? So if I take this cylinder, erase that, okay? I take this cylinder and open it up. What will I get? I will get 2 circles, right? The top and the bottom. And when I cut this side bit, I'll open it, I'll get a little rectangle. Okay? So if I want to calculate the surface area, the area that I need to, let's say, paint, if I paint all sides of it, okay, I need to calculate the area of the circle, times by 2 because they're identical, of course, and add the area of the rectangle. So how would I calculate the area of this circle? Let's say the radius is r, okay? So the area is going to be, obviously, okay, I'm just going to erase this bit, okay? The area is going to be pi r squared. Okay? That's area of one circle. But I've got two circles, so it's going to be 2 pi r squared. 2 pi r squared. So that will be the area of the two circles. How do we calculate the area of the rectangle? Well, we need to know these two lengths. Okay? Now this length, okay, is going to be the same as this length. Okay? Like this is the cylinder. If I cut it up, then this distance is basically that distance. So this length is h. We're going to give example numbers in a minute. Okay? But the question is, what is that length? Now that length is basically this whole, the circumference of the circle, right? If I was to open this, then the length of this rectangle is going to be the circumference of the circle. And we know how to calculate the circumference of the circle if we know the radius. Right? It's going to be 2 pi r. Okay? So what will be the area of this rectangle? It's going to be 2 pi r times h. So I need to add to the area of these two circles 2 pi r h. Okay? I'm going to just write that down. Okay? This was the volume. This is the formula for the volume. The formula for the surface area is 2 pi r squared plus 2 pi r h. Okay? Now let's go back to our examples. Let's work with the radius being 4 centimeters and a height being 5 centimeters. What will be the surface area? I'm going to put 2 pi times the radius squared. What's the radius? It's 4. And 4 squared. Plus 2 pi r, which again is the same as 4. And the height is 5. Okay? And I wouldn't mess around with that. I'll just put that straight into the calculator. Okay, so I've got 32 pi plus, I'm just doing it in my head, I'm doing 4 squared is 16, 16 times 2 is 32 pi, and here I do 5 times 4 is 20 times 20 times 2 is 40, so plus 40, not forgetting to multiply it by pi. You can just put it all in the calculator as it is, and you will get 72 pi. Okay, that's still not the final answer. Okay? Unless they tell you they want the answer in pi, you need to press the SD button. Okay, and I got 226.19. 226.19. Because I work with centimeters, this is surface area is always going to be square. So 226.19 centimeters square. Alright? Let's move on to some more examples. Okay, so now the next question I'd like you to do, we'll do together is B. Okay? We are, by the way, we're in page 247, exercise 4. Yeah, exercise 4. Okay, so we've got glass. Okay, that just looks at glass. It has like a base filled with glass, and this bit here, inside it's empty, so that's where we can put the water in. We're told this is 7 centimeters, this is 7 centimeters. So the first thing they want us to find is the volume, total volume for the drinking glass. Okay? Now I've got the answer in centimeters, millimeters, this is centimeters. I might as well work with centimeters. So 15 millimeters divided by 10 is 1.5 centimeters. So how do we calculate the volume? The volume is going to be pi r squared times h. What is the radius? Now here they didn't really give us the radius, but they gave us that. What is that? That's the diameter. So if the diameter is 7 centimeters from here to here, the radius, okay, will be half that. It will be 3.5. So it's going to be 3.5 squared times pi. Now we need to time by the height. Now what is the height? If this is 7 and this is 1.5, so altogether the height will be 8.5. I've just added them together. Okay? So that's centimeter, okay? And we'll find out the answer. 3.5 squared times 8.5 times pi equal SD, and I've got 327 and a little bit. 327, blah, 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 blah. Leave you to find that out, okay? And the answer obviously is in centimeter cube. Okay? Next thing they ask, what is the capacity of a drinking glass in milliliter? Now here we have to be a little bit careful. We said the capacity and volume are very similar, but not exactly the same. Volume is, well, it's volume. But capacity is how much liquid or sand we can fill in. Now, when we calculated the total volume, we added the base. This is solid glass. Okay? But obviously, when I pour liquid into it, I won't have liquid in there. So when I ask what's the capacity, it's not the volume that I just calculated, it's the volume of this. Okay? Not including the glass. So how am I going to do that? Okay? So the capacity, okay, is still going to be pi r squared times h. So it's going to be pi. What is the radius? It's still the same radius. The radius didn't change. Okay? What changed was the height. If the height before was 8.5, now we're just looking at the red bit, so the height is going to be 7. So I need to time that by 7. Okay? So let's do that. 3.5 squared times 7 times pi, and I'm getting 269.39. 269.39 centimeter cube, because I work with centimeters. Now the next question, okay, they're asking us what is the capacity of drinking glass in milliliter. Now if you remember, I raised it here, but 1 milliliter is equal to 1 centimeter cube. It's just one of these things you need to remember. Okay? So the answer for 3 will be exactly the same. It's still going to be 269.39, but now milliliter. Because each centimeter cube is the same as 1 milliliter. So it's the same answer, just different unit. At 4, they're asking us to calculate the capacity of the drinking glass in liters. If this is the answers in liters, how do we go from milliliter to liter? Okay? How do we go from millimeter to meter? Well, whenever we go to from milli to the normal, we divide by 1,000. 100 by 1,000. So the answer is going to be divided by 1,000. I don't need to calculate for that. I just move the decimal place 3 times. So the answer is going to be 0.269 liter. Okay, guys? Right. Let's do one more question together. Okay. Last question we're going to go over is C. Question C in 248. Page 248. Now, before you listen to me doing it, I want you to pause me and try on your own. Give it yourself 2, 3, 4 minutes to try and have a go at it. It's important that you have a go at it by yourself. If you just listen to my solution, you're not going to be able to do it on your own in the test. So give it a go. Even if you don't manage, see if you can steal a few of these marks. Right. We've got a straw. Okay? The measurement, the diameter is 7 millimeters and the length is 21 centimeter. We know we have 100 straws in a packet, and they want to know how much, how much plastic you need. What will be the surface area or amount of plastic required? In other words, the surface area of the plastic. Now, in a straw, okay, this is not a straw, but in a straw, you know that we don't have any plastic on the ends, right? It's open, so we can suck. Okay, so the only plastic is just around, okay, the little bit there. Okay, so there's no plastic at the top or the bottom, it's just around. So the surface area is not going to include the 2 pi r squared. I know I told you the surface area of the cylinder is 2 pi r squared plus 2 pi r h, but the 2 pi r squared were really the the top and bottom circles. And now we don't have any plastic there, otherwise we won't be able to suck any water. So the surface area is going to be just 2 pi r h. So you need to, this is why it's a bit of a difficult question, you need to really think here. Okay, there's no top and bottom. Okay, so 2 pi r h, right. 2 pi times r, what's the radius? Well, if the diameter is 7 millimeter, okay, the radius is going to be 3.5 millimeter. But we want to work with, let's say, centimeters, because we have centimeters here. Okay, so we're going to time it by 0. We have to divide by 10. So 7 millimeters divided by 10 is 0.7 centimeters. And we divide 0.7 by 2. It's going to be 0.35 squared. Okay, so 2 pi r, this is in centimeter, h. What is h? 21. Okay? So, am I finished? Almost. This is the area, the surface area for one straw. So for 100 stroke, we need to times it by 100. Okay? And we'll just put that in the calculator. I'll leave you to do that. Put that in the calculator as it is. You should get your answer in centimeters squared. Okay? Now, I'm not going to go over D. Okay? You're welcome to have a go at it. It's quite tricky. It's quite high level. I want you to have a go at it. I mean, if you want to have a go at it, if you don't want to have a go at it, it's fine. If you want to have a go at it, if you feel strong enough, go have a go at it. And then you can just contact me on WhatsApp and we'll see how it goes. Okay? See you in the next lesson.